It's a great computer stand. Okay. So we can see it behind me. We're all good with that? Okay. It is very DIY. Has been all year. So number one, it's asking you how many vertices this shape has. What is a vertice though?
A vertice is a corner or an angle.
It's the corner of your shape. So how many do we see here? 1, 2, 3, 4. How many vertices are there? 4. Nice and easy one right there. Vertices are the corners. I think the only issue is that you just had to remember what a vertice was, right? What's a vertex? Yep. Number 2, finding the median. This is the same set of data we used yesterday. So what do I need to do first? This is not in order. Least to greatest. One person raise your hand and tell me the order. Alex.
20, 21, 24, 26, 27, 28, 29.
Okay, do we agree? Was that right?
Yes, that was correct.
Okay, now that I have this, how do I find the median?
We have to cross out the outer.
Okay, we gotta find the middle, so we gotta go from the outside in. So we cross off our 29 and our 20. Go another step in, 28 and 21 go away. 27 and 24.
And you're left with.
We're left with 2. In this case, it's kind of easy though. What's the middle of 26 and 26?
26.
26, it doesn't really change. So our answer, our median is
26.
26. Right in the middle. Good.
I mean, when on a question like that, you think of any possible way. It could be like a decimal, but it can't.
No, this one is just, it's the same number, so that has to be our middle, I guess.
So far, I've got there you go. 100% on that.
Good. These two are a little bit challenging, so let's go ahead and go through these. We need to do order of operations on both, so we have PEMDAS, right?
Yep.
Let's start with number 3. We have parentheses. Do we see parentheses?
Yes.
On number 3?
Wait, I mean, no.
No parentheses. What about exponents?
Yes. Wait, no.
No exponents. What about multiplication and division?
Yes.
Remember, we do both of these at the same time. We go from left to right. So the first one we need to do is our 15 divided by 3. What's 15 divided by 3?
15 divided by 3 is
5. So we have 15 minus 5 plus 9 minus 7 times, you know, it's not my phone's in my pocket. I don't have a phone over there. My phone is right here. So I don't know.
I don't know that.
It's fine though. If it's yours, turn it on. Then we still have some multiplication to do. We did the division. Still have to do multiplication. Let's start with 7 times 2. So we have 15 minus 5 plus 9 minus. What's 7 times 2? 7 times 2?
14.
14. And then we have times 9. So what's our next step? Still, you gotta keep multiplying. 14 times 9. 15 minus 5 plus 9 minus. What is 14 times 9?
14 times 9 is
9 times
26.
126.
I did mine a little differently, right? No, I did it right. I did it right.
Okay. So now we've done our multiplication and division. What's the last steps we have to do?
Wait, I did do it differently. I did 18 times 7.
Subtract and add. Addition, yeah. We're at the addition and subtraction set. And remember, you still have to do these together. So now we just go from left to right. So we have to do 15 minus 5 first. What is that? What? 10. Plus 9 minus 126. Now still go left to right. What is 10 plus 9? 19 minus 126. Now our last step, 19 minus 126. This goes into the negatives. How do I do this? What do I do?
You have to change out the extras first. Wait, no.
No, we're still working on 19 minus 26, 126.
Subtract 19 by. It'll equal 117, but you'll have to put it negative.
Good. We need to take our bigger number, 126, subtract the smaller one. So we subtract and we get
107.
107.
Negative 107.
Why is it negative, Charlie?
Because the small one is actually subtracting the bigger one.
Yes, this bigger number right here has the negative in front of it, so our answer is negative 107 on that. That's the hard part, the negatives. I think you guys are good with the order operations and doing it. Yeah. I think you guys are good with the order of operations and stuff until we get to the negatives. Yeah. Okay, last one we need to do. When x equals 8. So we have 25 divided by 5 minus 16 divided by x plus x squared. What do I have to do with this?
Put the 8 with the 8.
Good. Replace our x's with the number 8. So we have 25 divided by 5 minus 16 divided by, this x needs to be replaced with 8 plus this x also needs to be replaced with 8. Now we do order of operations. Oh yeah. Do we see parentheses first?
No.
No. Do we see exponents?
Yeah.
Yeah, we have to do this first. 8 squared. How do you do 8 squared?
8 times 8 times 8 times 8 times 8 times 8 times 8.
That's way too.
Teachers at this time, will you release your track students to the
See you,
track
Charlie.
at the school?
Bye, Charlie. Good luck.
When
8 squared is just 8 times 8. You only have to do it twice. Wait, Charlie, you have to clean your area. You're gone for the rest of the day. Clean your stuff up, get it all wiped down. Then you can head to the office.
he just left.
I know, I saw that. You're like, what?
I have a right
Okay.
angle in my ear.
So, what is 8 times 8?
8 times 8 is 64.
Thank you.
I got 8 and I got 6 on the floor.
So 8 times 8 is 64. Now we have, we've done parentheses, exponents. What about the multiplication and division?
Nope. Well, yes, there's some.
There's division. We gotta do this division. So let's start with 25 divided by 5. That is 5. 16 divided by 8 plus 64. What do we need to do next?
You divide by 16 and 8.
Good. 16 divided by 8 is,
I don't know.
16 divided by 8 is 2 plus 64. So we've done our multiplication and division. Now we need to do, thank you, Charlie, addition and subtraction. Now we just go from left to right. What is 5 minus 2?
Wait, what? 5 minus 2 is 3.
5 minus 2 is 3
I got every single answer.
plus 64. What is 3 plus 64?
12.
3 plus 64.
7. 67.
67 is our answer on that
I
one.
don't know how I got 123.
I don't know either.
Yeah.
Sometimes if you do the order wrong, maybe that's what happens.
I know, I went like this. So I did the 16 divided by 8 first, then 25 divided by 5. Then I did the exponents. Then I did 5 minus 2 plus 64. And I summed my y.
Maybe you just added wrong.
Yeah.
Oh no, it happens.
Maybe I multiplied it. That's what I did. I multiplied
Ah.
thing and then subtracted by 5.
Yeah, that would be it. Okay, let's go ahead and work on
Our work.
the notes that we have for today. So I'm going to present my screen. We have 2 things we're going to look at. We're going to start with one and see how far we get, and then we'll look at the next one. I think they're both kind of short, though. So over on Google Classroom, I think it posted. Let's see. It did? Okay, so we have under math, tables and equations. So we're going to talk about using equations to create tables and tables to create equations. The first one we're doing, though, is the using tables one. That's the one I want to start with, and then we'll do equations from tables. So start with the using tables. Open that one, please.
Wait, is this kind of what we were doing?
It goes along with the independent and dependent variables, yes. We're just going to keep building on that stuff.
Wait, can we skip the warm-up stuff? No.
Yeah, we're probably gonna, well, we'll do one of them maybe. We'll see. So, take about 1 minute. Go ahead and get that opened up, please. I'm gonna check attendance. Make sure everybody's doing what they're supposed to be doing. Okay. go ahead and get the using tables PowerPoint opened up. And we will start going over it. I'm going to do the presentation slides so that we can look at it as a presentation. You guys can either look at my screen or have it open on yours. We will type on it in a little bit though, so keep that in mind. Move this closer. Okay. Our first thing is using tables. Here we go. So this warm-up asks us to identify the independent and dependent variables. So if you look at our first one, Joe's car is traveling 55 miles per hour on a trip to the beach.
Wait, so he's driving 55 miles.
55 miles.
He's driving 55 miles.
Yeah. In 1 hour, he drives 55 miles. In 2 hours, he drives 110.
Okay, if you're going 75, then you're going to do 75 miles every hour.
Yeah.
So then 4.5 hours travel.
Independent variable. What can change on this? What changes? The miles or the hours? The hours will change. That's your independent variable. The time that you drive gives you the distance, right? The miles. So the miles is your dependent variable. All right. Hopefully you guys finished up your assignment from yesterday. This is very similar to your assignments from yesterday, right? I don't think we need to do any more. We did this all yesterday. So let's go ahead and keep going on our slides. Our next one. Too far. There we go. So we're going to talk about using the idea of like 1 hour is 55 miles. 2 hours means that you drive 110 miles. 3 hours means you drive 165 miles, right? We're going to use that idea to create charts and tables and graphs and all of that stuff that is so fun. So example 1 says that John makes $5 for every lawn that he mows. That is not a lot of money. He mows.
Yeah.
And then asks us how much money will he make if he mows 4 lawns, 6 lawns, 100.
Oh,
So
you have to find the money that you'll make if you know that much.
yeah.
Oh.
So we're going to find the amount of money he makes if he mows 4 lawns, 6 lawns, and 100 lawns. But we know that for every one that he mows, it's $5. So the number of lawns that he mows can change, right? That's where we're getting 4, 6, 100 lawns. Huh? Yeah, that would be a lot of money. So the amount of lawns that he mows changes, and the money he makes depends on it. So the money is the dependent variable, and the lawns is the independent variable. So we can use a table to record our data here. Let's see what it gives us. So let's start with, you don't have to type into these, I don't think, for the first couple. So we know that if he mows 1 lawn, he's going to make $5. How do we figure out how much money he makes if he mows 4 lawns?
Times 5 equals how much money?
Okay, you multiply the 4 lawns times the amount of money he makes per lawn. So we would take 4 lawns times $5 and get how much money?
We would make 20 bucks.
20 bucks if he mows 4 lawns. What about if he mows 6 lawns?
30 bucks.
30. 6 times 5 is 30. What about 100 lawns?
500 bucks.
That wasn't ours, right?
No.
Okay. If he mows 100 lawns and we multiply that by $5, how much money will he make?
500 bucks.
$500. That would be nice to make $500.
550 bucks.
My thought process is if you have enough business to mow 100 lawns, you should up your price and make it $10 a lawn. Make some profit there.
I charged my grandparents $50.
Yeah. You got to charge what you're worth, right? If you're good at what you do, you got to charge more money for it. Anyway, so do you see how the table comes in right there? We took the amount of lawns, multiplied it, and we have a table. Okay, let's try another one. Example number 1 again. Okay. Oh, it asks us, how did we get the values in the total column? So if we're back over here, it's asking us, how did we get the $20, $30, and $500? Yeah, I know it says it right there. So we took the number of lawns and multiplied it by $5. That's how we got 20, 30, and 500 on these. I don't know. Let's try example number 2. Bob's SUV gets 18 miles per gallon. How many miles can he go on 3 gallons, 6 gallons, and 9 gallons? So the amount of gallons is 3, and each gallon can get you 18 miles. So how do we figure out how many total miles? What do we need to do to find the total amount of miles he can drive with 3 gallons?
Multiply.
Multiply. You're going to take the number 3, multiply it by 18 to get how far he drove. What is 3 times 18? Is it already on the slides? Okay, that's good. So it's 54. He can drive 54 miles if he buys 3 gallons of gas. Right? What about if he wants 6 gallons of gas? How far can he drive then? How do we find that?
96.
96? I don't actually know the answer, but how did you find that?
No, it's not 96.
But what would you do? You have the right idea. What do you have to do?
Multiply.
Multiply. Yep. We need to multiply 6 gallons times 18 miles to figure out how many miles he can go. I did the math on my calculator because I can do that as the teacher, and I got 108 miles. 108 miles. If you buy 6. Yeah, you were close. You're just a little bit off.
Wait, so you have to multiply it by 8 every time?
18, yeah, because it's 18 miles per gallon. So if we,
They're all different things that don't match up with the numbers.
it should be consistent all the way across.
So on that one, I just write the number, like what it's multiplied by.
We'll talk about that in a few minutes. Yeah. The next one, if we buy 9 gallons, how far is Bob going to be able to drive?
162 miles.
160, yeah.
Yep, 162 miles. We took the number 9 gallons, multiplied it by 18 miles, and you get 162 miles. You see how we're just multiplying every time?
Yeah.
It's gonna get a little bit harder. It might be multiply and then add, or multiply and then subtract sometimes.
Oh, that's it for
So again, it's asking how did we get the value in the miles part? What did we do? Multiply the number of gallons by 18. Good. Is there any that is not filled out already for you? Are they all filled out? All right, well, let's do a couple more because this is one that I want to talk about in terms of it's not always just multiplying. So on this one, Paul's Pizza Palace. Say that 5 times fast. Yeah. They charge $10 for a large pizza, plus $2 for each time you want to add a topping. So if you want a pepperoni pizza, that is 1 topping, they're going to charge you an extra $2. If you want pepperoni and jalapenos, that's 2 toppings, so they're going to charge $4 extra, right? So it's asking you, how much does it cost to buy a large cheese pizza with 2 toppings, 3 toppings, and 4 toppings?
$14?
For 2 toppings, yeah, it will be 14. So the number of toppings, if we do 2, it's the $10 base charge plus $2 per topping. So we need to take the number 2, multiply it by 2, and you get 4, plus the $10 charge for the pizza. So you get 14.
So multiply it then.
Yeah. So if I were to write the equation on the board that we're using for this, it would be 2x, where x is the number of toppings, plus the $10 fee. So it's 2 times the number of toppings plus $10. So we're doing that over and over. So if we do the next one, 3 toppings, it would be 2 times 3 plus 10. What is 2 times 3? 6 plus 10 is $16 for a pizza with 3 toppings. What about 4 toppings? Yep, take 2, multiply by 4 for the price of the toppings, plus the $10 fee for your pizza. So that would be 8 plus 10, which is 18 on that one. We see how that works a little bit? This is where it gets a little bit harder when you have to do 2 steps on your equations, right?
Is there a way you can do 3 steps?
Oh yeah, there are steps. Yeah, you'll get there. Junior high and high school, it'll get longer. So for this one, it's asking you again, how do you find the total cost? You're taking the number of toppings, multiplying it by 2, plus $10 for just having the cheese pizza on the bottom.
You can just add 10 and 2 and multiply it,
No, because that would be 12 times whatever. Right?
but you could add it.
Yeah, you have to do the $2 times the number of toppings first, and then add the regular fee, the $10 for your pizza. Okay. This one is again another one just like that. Frozen yogurt costs $3.50 for a medium serving and 75 cents for each topping. How much will a yogurt cost for 2 toppings, 3 toppings, and 4 toppings? First, we need to figure out the independent and dependent variable. So does the cost of your yogurt depend on the number of toppings?
Yes.
Yeah, that is correct. It does. The amount of toppings you buy is going to change the price of your total yogurt, right? So if you buy 8 toppings, it's going to make your price go up a lot, right? So the independent variable is the number of toppings. Oops, wow, okay, we'll just go for it. And the dependent variable is the price of your yogurt. How do we get these numbers here? We know that the toppings is 2, 3, and 4. How did I get the cost though?
You'd have to.
They multiply 75 cents times 2 toppings.
Yeah.
Then you'd have to add something.
You would have to add something. You are correct. So we are taking.
Oh, you'd have to add the $3.50.
Good. We're taking the number of toppings, which is our X value. It changes. We don't know what it is. We're multiplying that by 75 cents. So 70.75 times the number of toppings. And then we're adding how much money for just buying a yogurt alone without toppings. How much is one yogurt with no toppings?
No.
Yeah, you're right. $3.50. So your yogurt, if you want no toppings, you just want plain vanilla yogurt, is $3.50. If you want to add toppings, it's 75 cents times the number of toppings you add.
But is the yogurt pretty much like ice cream though?
Frozen yogurt is kind of like ice cream, it's just healthier. So if we needed to find the price of 2 toppings, we would do 0.75 times 2 toppings plus the $3.50 for just the base of the yogurt, right? Dana, can you please stop drawing during my lesson? Sorry, I don't know what you're doing, but stop. Focus, please.
Okay.
So in order to do that, 70.75 times 2 is $1.50 plus $3.50 is $5. That's where they got their $5. And then if we wanted 3 toppings, we would multiply this by 3 instead, and you would get a different answer. If you wanted 4 toppings, you would multiply it by 4, and you get another different answer, right? And it all goes up by 0.75. If you look at that closely, if you want 2 toppings, $5. If you want 3 toppings, the price goes up by 75 cents. It adds together, right? If you want 4 toppings, the price goes up by 75 cents. Most of the time, if you're looking at these tables that they give you, there's always a pattern. That's how you figure out the equation from it. They always give you a pattern to go off of. Or you have to find it. That's the hard part sometimes, finding the pattern. But you get more used to it as you go on. Although I'm not going to lie, there are some times when I'm given a table and they ask me to find a pattern and find the equation. It takes a while sometimes. It gets harder and harder for sure.
No.
Yeah, we're going to skip the closure. I don't want to do it. So, there is a little bit of an introduction to tables and how we can see that they kind of go together. There's always a pattern. Bradford, I don't know what you're doing, but put it away as well. Okay, let's go ahead and look at the other Google Slides that they gave us. So this was practice and notes. There wasn't any practice on it, I guess. Let's open the writing equations from tables and talk about how to. There's work to do on this one?
Mm-hmm. But you'd have to write what the dependent variable is.
Okay. So let's start with the warm-up though and talk about the warm-up a little bit. This time John is asking for more money when he does this. That's good. Good for him. There's a guitar. Someone is carrying a guitar. Huh?
He wears a big red jacket and then it's called Big Red.
Oh, okay. So we have for this warm up on the writing equations from tables. You guys, I guess I should give you a second to get it open. Okay. Open it up. Have it ready, please. Go to math, please. Okay. So for this warm up, it's very much like what we just did. John gets paid $15 for every lawn that he mows. How much money will he get if he mows 3 lawns, 6 lawns, 20? So the first thing we want to do, there's a text box right here. So go ahead and click on that. We need to first talk about what the independent and the dependent variable are, just as a review. Good. So the money he makes depends on the lawns that he mows. So our independent variable is the number of lawns. What's our dependent? What depends on the number of lawns he mows? Money. The amount of money he makes. Money made depends on the number of lawns he mows. And then we need to fill out our table here. Before we do that, I think we could write an equation from it really quick. The way that equations work is you will always have something that says y equals your equation, whatever's happening in the thing. Because when you look at this, the left side of your equation is your x values. It's what you plug in for your x in your equation. And then whatever is popped out of your equation is the y value. And we will actually start graphing these too, because x's and y's can be graphed on a coordinate plane. Nice and fun. This is algebra. We're getting into the beginnings of algebra so that when you go to junior high, you have some ideas of what algebra is before they really get into the stuff, right? So for this one, we know that we are taking $15 and multiplying it by the number of lawns. So what am I doing? How do I find the price paid here? 15 times 3. What about for 6? 15 times 6. What about 20? 15 times 20. What number stays the same in all of those? 15. So when you write your equation, the 15 will always be there. 15 is being multiplied by whatever x value we want to put in. So that would be 15 times x, which is your equation, 15x. 15 multiplied times x. So sometimes they will give, yes, write this down, please. Sometimes they'll just give you an equation like this, y equals 15x, and you'll have to fill out a chart and choose the x values that you want to use. Yeah, exactly. And then you can plot your points. We'll get into that next week. So for this one, we are taking for the price paid, you guys said it multiple times, 15 times 3, which is, you guys did that already? $45. Good. Okay. What about for 6? What was that? 15 times 6. Yes, it is 90. 15 times 6 is $90. Did anybody do 15 times 20?
Yep.
What, 300? 15 times $20 is $300. So if we look at that and compare it to our equation that we just talked about, 15 times x, this 3 and the 6 and the 20 that we put in are our x values. It's whatever we chose for x, or whatever they told us in this case. And then you multiply it, and you got your answer. Sometimes it'll say multiply these together and then add a
We're
number.
supposed to put the equations in it. I just put the answers.
That's fine. I just showed it to show how we got it. Okay. I'll give you about 1 more minute to get that written down, and then we will look at some other ones. Alright. Let's move on to slide number 3, where we're going to talk about the stuff. It's already kind of written down there, so we're just going to talk through what is happening here. I'm going to zoom out a little bit. So, we're looking at a table here, right? On the left, we always have the x values. It's the ones that you plug in to your equation to get your y values. When I was younger and when I was in school, they called it the equation machine. So they would like draw or give you a worksheet, right, that had like this big thing in it, and they called it the equation machine. And it would always have arms like this. So they would say your equation is y equals x plus 4. And they would say plug in for x equals 2. And that's where you would say, okay, 2 goes in, blah, blah, blah. And then you would say x is 2 plus 4. It spits it out and you get 6. You see what I mean? It goes in and comes out. They call it the equation machine. So you take whatever x value they give you, plug it into your equation, and it outputs your y. Y equals 6. So equation machine. I like to think about it like that too. So if we look at the chart that it gives us right here, we plug in a 1 to our equation machine, and it spits out a 6. And then we plug in a 3, and it spits out an 8. Plug in a 5, it spits out a 10. What is happening to get these next numbers?
You have to add by 5.
We're adding 5. So I know it says it right there too, but
Oh, I didn't even look at that.
y equals x plus 5. So you're always adding 5 to get the y output. Plug in 5, add 5, you get 10. Plug in 7, add 5, you get 12. You see how that works? It's an equation machine.
Also, that's what that is on that chart.
That's what you're going to be doing in there, yeah, on that one. So basically what you have to do is look at the tables
Also,
closely.
not multiplying on that.
Sometimes it's adding, sometimes it's multiplying, sometimes it's subtracting, sometimes it's a combination. So a lot of times they'll multiply and add or subtract. So they can get a little complicated. That's what I mean when I said that sometimes it takes a while to figure these out. So there's our first example. Let's look at slide number next one. This one, again, gives you the thing, but let's look at it in terms of our equation machine. If we have an x, we plug in the number 2, it does whatever inside the machine, and it spits out a 14. We could either be adding 12 or multiplying by 7, right? There's 2 things that we could do there. Or we could look at our next one. Plug in a 5, spits out a 35. That's adding 33. Is that the same as what happened in the first one? In the first one, we either added 12 or multiplied by 7. So it's not the same. But 5 times 7 is 35. So we're multiplying by 7. Does that work for 2 times 7 is 14? Does it work for 5 times 7 is 35? What about if we plug in a 7? 7 times 7 is 49?
49, yeah.
Yeah. So a lot of the times it's just trial and error. You have to guess and check to see what works and what does not. So that's the next one. We're multiplying the x values by 7 to get the y values. Let's look at our next one. I wonder if there's one where they don't give us an answer. There's some down here at the bottom. Yeah, let's do one more together. So again, our equation machine. I know it says our equation right there. Let's write it down this time. Y equals x plus 4. If I say that,
How do you know what
Y is what happens when you spit it out and you do your work, right? So if X is 15 on this one, we plug in the number 15. It goes down through our equation machine. X is 15, so we replace it with the X with 15. Add 4. What's 15 plus 4?
15 plus 4 is 19.
Is 19. Y equals 19. Is that what it looks like on our first one right there? 15 to 19. What about if I plug in 20? 20 plus 4 is 24. Is that correct? So what we get? So our equation machine is doing its work correctly, right?
I'm drawing it with a loopy-loop on it.
A loop-de-loop works for me, yeah. So these ones have given us the equation as we look at it. Let's go try a couple where it doesn't give us the equation. So skip slide number 6. This one is a little more complicated. You multiply by 2 on this one and then have to add 1. That's fun. Let's look at slide number 7 and try a couple of these. Okay. I'm going to leave my equation machine up for now. This is where the trial and error and the guess and check comes in. We have to try different things about what our equation is. So in this one, we have x's and y's. Our first x is 0, then 6, 5, 11, and 11 to 17. Thank you. So we have to figure out what's happening here. How do I go from 0 to 6? We can add what? We can add 6. That works. Is there another way to go from 0 to 6?
Multiply.
How do you multiply to get to 6?
3 times 2.
3 times. Well, we have to plug in 0. We have to use the 0. How are we subtracting to get there? 0 minus 6 is negative 6, though. So 6 minus 0. In this case, though, this adding 6 works, right? What about this one? From 5 to 10. We can add 6. I heard multiply. That's a good point. We could multiply by something and subtract to get to 11, right?
Does the 6 have to go into all of them?
Yeah, the rule has to work for all 3 of the ordered pairs we're making, right? So another way that we could get to 11 from 5 is we could multiply by 3, times by 3, and then subtract 4. That gets us to 11, right? 3 times 5 is 15, minus 4 is 11. And then we have to check to see if that works for the other ones, though. Because it might not.
Yeah.
Let's look at this one. For this one, how can we go from 11 to 17? What's one way? The easier way. We could just add 6 again. Let's check our 3 times the number minus 4. This should be 3 times 11 minus 4. What is 3 times 11?
33.
33 minus 4?
29.
29. So does that give us 17?
No.
No, so that rule doesn't work.
It's just add 6.
So that means that this one can't work. Does adding 6 to each one work? Yeah. So our equation is what? How do I write that if I'm adding 6 to
You
something?
would write y equals 6.
Not y equals 6. We still have to do something. We know we're adding 6. To what though?
X.
Our x values. Y equals whatever x value we want to put in plus 6. And then we could do all of our function machines and get 6, 11, and 17. So there's a lot of guess and check on this. Did you kind of see the process of it though?
Yeah.
Lots of ways to get to these different numbers. So that first one, your equation, is there a place to type it?
Nope, here's not.
There's not a place to type it, but that's
There
okay.
is.
Where?
In the middle.
Oh, cool. So we can do y equals, wow, it's so small, x plus 6.
Wait. What if you have, like, on the next one, it's just 3, and, like, you're adding? Because the rule is, 3 times, wait, so it'd
The
be
next one's a little bit hard, huh?
y equals x times
I don't know, I haven't looked at it close enough yet. We'll look at it though. So let's look at our next one. Number 2, our x values and our y values. We have 0 and 3. We have 2 and 9 and 4 and 15. So the first thing I like to check is to see if anything multiplies really easily. Does 0 times anything give you 3?
No.
No, because if you multiply anything by 0, what do you get?
0.
0. So you can't, this isn't multiplying just one thing, right? It's not 3 times x, right? So what are you doing? Okay, if it's not math, close it, please. Okay. So, we're not just multiplying. What about adding? Are we adding anything here? Maybe.
Yeah.
We know to get from 0 to 3, what do?
Add.
We could just be adding 3 here. But if we look at our next one, is 2 plus 3 9?
No.
No, that one doesn't work, right? This gets a little tricky, huh? What are,
Times. It's times 3 plus 3.
times 3 plus 3?
Yeah, if you do 3 times 2 is 6 plus 3 equals 9. And if you do it on the bottom, that's 3 times 4 equals 12 plus 3.
Okay, so Dallin has a suggestion. He thinks we're gonna do 3 times our x value.
Because
Plus
we did
3.
that one, 3 times 0 plus 3.
Okay, Jada, you have a question? Yeah. So let's check it. Dallin thinks that we're gonna multiply this x value by 3 and then add another 3. So if we do that, 3 times 0 plus 3. Order of operations, what do we do first?
Multiplication.
Multiply. What's 3 times 0?
0.
And then we add 3 and we get 3. So our first one checks out. Let's try it again. Our next one is 3 times what number? Times 2 plus 3. So what do I do first?
Multiply 3 times 2
3 times 2 is 6 plus 3
equals 9.
is 9. This one works. Let's check our last one. 3, oops, I don't want to use an x. 3 times what? 4. Plus 3. What is 3 times 4?
12.
Plus 3
Yep.
is?
15.
Does that work for that one?
Yeah.
Guess and check. Right? That works. That's our equation. Y equals 3 times whatever our x value is plus 3. Right? There's our equation. It's a lot of guess and check. There's not really any other way to do this except for guessing and checking. Ash?
Are we gonna do some on our own?
We only have about 5 minutes left of class. Tomorrow is when we're going to do practice on our own. So, you're more than welcome to finish these 2 on your own, number 3 and 4. But well, 1, my computer's going to die. 2, we have to go to lunch here. So I think I'm going to end class here. We'll do a couple practice ones at the beginning of class tomorrow, and then you guys will try them on your own tomorrow. So, yeah. You guys can get this turned in. And those of you online, we will see you at 12:30 for science.